All right, so what's going to happen next is going to feel a little bit more like review. We're going to be going over some of the basics of JavaScript and some of the basics of Python. So I'm just kind of some things we didn't cover the last couple of days explicitly, but you've all been doing this entire time. So first I want to talk about JavaScript, specifically control flow in JavaScript. Have y'all encountered that term before, control flow? I heard a yes or a no. Does someone who has heard that term before want to take a crack at explaining it?
So there's a sequence of commands that your programming script follows, right?
Mm-hmm.
And this is like how you write, hey, initialize a variable, and then write a method or a function or whatever. So that sequence is pretty much the control flow, and you can affect it in different ways by using if statements or loops to make it repeat itself, or skip parts of the code by using an if statement. And you can use a return to exit early out of a function.
Yeah, that's good. So talk about code has a way that it executes, a certain order, right? Order of operations. Yeah, and that usually goes from top of the page to the bottom of the page. You know, if I do hello, and then console.log world, you should know that if I go node JavaScript control flow, we should see hello and then world, because that's the order it goes in, like that. A control flow says, okay, sometimes I don't want it to necessarily just go in the order it is. Sometimes I want to make sure that only certain things happen, or that they happen in a certain way. And that's where control flow comes in. And kind of to understand control flow, you kind of need to understand a little bit more about how computers think, for lack of a better word. So let's talk about decision making. Who here wants to share what they had for breakfast this morning? Yes.
Greek yogurt, blueberries, cinnamon granola.
Okay, why that?
My wife said, "Hey, you should try this." And it was sitting out there and easy to make.
Okay, so for a human being, that's a pretty simple judgment call to make. You probably didn't even have to think about it that much. It was simple, like, this food is here. She says it's good. Probably I'm going to try it. A computer needs to break that down into smaller steps. So a computer would say, the way we can translate that into computer might be, if I am hungry, and if the food is good, or looks good, then I will eat it. We don't think that way, usually. We don't think in terms of ifs and elses. We just think of yes or no. But a computer has to kind of do this in another way. So I go something like, set up a variable, so I could say let's say I want to eat something for breakfast, so I'm going to say Noah wants equals coffee. So I could set up an if statement that just says, if Noah wants equals coffee, then I do something. Okay, so let's talk about, kind of break this down a little bit. We have if. What is if doing with this thing in the parentheses right here?
It's comparing.
It's comparing, I heard? What is it comparing?
Type value. The input.
Yeah. Yeah. Yeah, so it's comparing this variable Noah wants with this string coffee. And this will evaluate to, this statement right here evaluates to what data type?
A Boolean.
Boolean.
A Boolean, exactly. So what if does is it says, I'm going to evaluate whatever you put in those parentheses and say, if this is truthy, if this is true, I will console.log, I will run whatever code is in this block. And it's actually kind of interesting is that what coding languages consider to be true So I say if Noah wants coffee, I should be able to, if I run this code, there it goes. What if I just do, oops, what did I just do there? What do you think is going to happen if I leave it like this? Yeah, because Noah wants is a variable that points to a string, and it's a string with characters in it, and JavaScript goes, okay, this is, like if can only read it as true or false, and it reads a string like that as true, because it's probably not false.
Which fits. We know he wants some.
Yeah, so if I did it more as a Boolean variable, if let Noah wants coffee equal true, then I could say Noah wants coffee. If Noah wants coffee, same thing. If I set it to false, at the moment, if I set it to false, what do we expect to do when I run this program?
Nothing.
Nothing. We didn't tell it what else to do. The if statement gets triggered, says, okay, this is false. Great. So it didn't know what to do after that. We reached the end of the program. But we can also split it off and say, all right, we can make other things. So if we wanted to say, all right, let's say there is something else that says, I'm going to put this back into Noah wants equals coffee, just for the sake of this. Then we could say else if. Then we could say if Noah wants tea instead. Equals. I can also do that here. Then I could say so in this case, we have Noah want. So we're reading the control flow of this. Run the program. What's gonna happen first? What do we expect to print? To the screen? Yep, caffeine. If I do this, then what? Trying to cut back because it'll say, okay, if I want coffee, do this. If I want tea, do that. And it always checks in that order. It'll always go down that list, like checking off a list. It'll say, do you want coffee? No. Do you want tea? No. And then once it goes through exhausts all of these options, we can say, else just a glass of water, thanks. So now if it's anything else besides coffee or tea, we get just a glass of water, thanks. All right, cool. And there's kind of one other way we can edit this to have change the Boolean logic, because we talk about, if this is true. But what if there's more than one condition that needs to happen for it to evaluate to true?
You could use a switch. You could use a ternary.
So I heard a switch and a ternary operator.
You can use the double ampersands.
And double ampersands. I heard 3 answers. So let's take those one at a time. So when you say switch statement, what do you mean?
Wait, is that Python? Or, I think there are switch statements in JavaScript, right?
Yes, there are switch statements in JavaScript.
Yeah, it's you just put in the possibilities, and it goes down the list until one of the possibilities matches.
Yeah,
it's just like if else, but just trigger it.
Yeah, so it's a more concise way of doing an if else if kind of flow. But so that's absolutely true, and those are very useful. But it's not really answering my question right now. If I said, so for example, if I wanted to say this only happens if Noah wants equals coffee and coffee pot equals full, for example, like.
You can single line those case statements, like case 0 and case 1.
I think the double ampersand would be the quickest way, right?
Mm-hmm. Yeah. So double ampersand I've heard twice now. What does that mean?
It's saying that if both conditions are true, then it's everything.
Yeah. So So in this case, yeah, that's exactly what it means. The double ampersand just means and it's just saying, okay, both of these things need to evaluate to true in order for this, this code to run. If either one of them isn't, if I do empty, then it'll still do, it should go to just a glass of water, thanks. But if it's full, then both of them do that. And kind of the, I won't say the opposite of this, the and, but what's the kind of the alternative to it?
Double pipes.
Double pipes, which is how we express or. So in this case, or doesn't mean both have to be true. What do I say? No one wants coffee equals, if no one wants coffee or coffee pot equals full.
At least one of them is true.
So as long as one of them is true, it'll still go. Which is not a healthy attitude to have if I just drink whenever the coffee pot is full, but here we are. My old instructor used to tell me that a developer is a machine that converts coffee into code. Okay. Any questions about if-else statements? Okay.
What's
Yes.
the difference between else if or else? Is that just for the coder, like if someone else is looking at your code just to know this is the last line? Because it doesn't perform differently, right?
Good question. So if we look at kind of the statement I have here. So the first option is if no one wants coffee and the coffee pot is full. I do this. Else if it says there's another possible condition. If what no one wants is tea. Else just says, okay, if none of the above options are true, this is what you do as a default. So in this case, so I couldn't say, and so else if is just pretty much saying, if this is happening, do this. If this is happening, do this. Else just says, okay, if nothing above this is true, then here's what we do. So it's else is kind of your, what's a good word? What's a good last resort? That's a good way of putting it. This is the thing that runs if nothing else evaluates to true.
It's like a catch-all.
Catch-all, yeah. And when you do a case statement, they usually explicitly label it as a default instead of an else. Or at least I think it is in some languages. I think in JavaScript it's case when default. Yeah. So that's actually a little more explicit about what the else is for. But I think in other languages that it goes actually case when else. So you can think of else as a default and else if as just another option. Which actually kind of raises another point. What's the difference between saying if Noah wants coffee, else if, or if I just do if? What's the difference between how these run?
It is possible for line 6 and line 9 to be true, so that you would have a printout twice of two different things.
Exactly. So.
Oh, because it's with else ifs. If it hits one of them, it stops checking anything else, right? But
Exactly.
if there's separate ifs, it would check every single one.
Yeah. So if Noah, so if I put this to coffee right here, so it would check if I need this, and then it would get here. And since there's no else if or else, it would just go, okay, what's the next thing? Oh, now I want to check if Noah wants tea. And else if would hit this first part, see it evaluates to true, and then not bother running this code at all. So there's good reasons to use true if statements. There's good reasons to use if else ifs. It's all situational depending on what you need to check and how often. Put that back the way it was. Cool. Any other questions about if else ifs? All right, moving on. So let's talk a bit about loops. So in basic terms, what is a loop? Explain it to me like I'm a child.
It's gonna do the same thing over and over again until you tell it to stop.
So going around in circles, doing the same thing over and over again until you stop. So in other words, code that runs multiple times. And why is that useful to us? Why do we want our code to run over and over and over again instead of just once?
Saves time.
Saves time, right? That's really what computers are, why we have computers, is not only can they do things faster than us, they can do things repetitively faster than us. They never get bored. They'll keep running until we either tell them to stop or they should run out of power, whichever comes first. So there's many ways we can do that, and many ways we can loop. And JavaScript has a few. Probably the one we've used the most is the for loop, right? So if I'm going to write a basic for loop, I'm going to say for. There we go. Let I equal 0, I is less than 10, I plus plus.
Equal.
Oh, thank you. I 0. Okay. So let's break this down into little pieces again. So so I have this for loop, and inside this for loop, and then I've got the parentheses. What's happening inside those parentheses?
You initialize a variable is the first thing. Then there's a condition. That's the second part, and the third part is change the variable.
Okay, cool. So yeah, we define a variable, set it equal to 0 in this case. Then we have a condition. And what is that conditional doing? Like, what is that conditional telling our for loop? When to stop. Or more technically, like when to stop is how it comes out. It's technically speaking when to keep going. Okay. So it's saying when it's I is less than 0, keep doing this. And then when that stops being true, then we stop. So it's like comes out to almost the same thing. It just depends on how you read it. And then I++, we're increasing it. So we're saying every time we go through the iteration, every time we loop through it, here's what you do. In this case, we're saying increase I by 1. And that's how so now we know, by doing that, we can make sure this isn't an eternal loop because we know that eventually I has to get greater than 10 because it's going up by 1 from 0. So I can just say, console.log I. So we get 0 through 9. Right. We've done these a couple of times. And of course, so if I did something like that would never evaluate to false, like I minus minus, so starting at 0 and counting down, what happens?
It's an infinite loop.
That's an infinite loop because this condition is never proven false. So I'm not going to run it because that would be a mess, but so whenever you're setting up your for loops, you always got to make sure, and any kind of loop, you always got to make sure that there's some kind of exit condition. All right, so that's pretty simple. Loop, for loop. There's another kind of loop that we use called a while loop. So difference between so in this case, I could say something like this. So I could say let counter equal 1. Or let's set it to 0. So you can say while counter is less than 10. Console.log counter plus plus. So let's break this down. So I have a variable called counter. Then I have my while loop. And my while loop takes a look at this, and what does it say? Like, what is it telling my computer to do?
Since while this condition is true, repeat this code within brackets.
Exactly. So it's while this condition is true, keep doing this. Every time you go through it, check to see if it's false. If it's not false, do it again. Is there any difference between this and this? None whatsoever. A for loop and a while loop, when set up in this particular way, are more or less doing the same thing. I've just changed the order of how I do things. I do it all in this block instead of right here. So if I set up a while loop like this, we'll do the same thing that a for loop would do. So in this particular case, there's not really much point to doing that, but I could have something here that inside the while loop that could change about whether or not or by how much the counter goes up. So I could say something like if I divided by 2, modulo 2 equals 0. Oops, counter is what I meant to say. Counter plus equals 2 in that case. Else counter plus equals, or counter plus plus. So with a while loop, I have a little more freedom about how I can change things around, instead of just making sure it has to iterate or go up by a certain number every time. So if I do that, I didn't console.log anything here, that's why. So before I hit that, console.log counter. So in this case, I have 0, 2, 4, 6, 8. Kind of a silly program. All right, any questions about while loops? Or for loops? Loops in general.
Do you favor one or the other? I mean, like you said, they're the same. I heard that, but I mean, just for simplicity, performance, etc.
In this case, it's more of a situational thing, using the right tool for the job.
Mm-hmm.
Usually I would say, if I know that I'm going to be repeating something a finite number of times and I know what that number is going to be, then a for loop makes more sense. Because then I can just say, all right, if I need to do something 10 times, this for loop setup is perfect. Because I have a counter, it says until it hits 10, move that counter up by 1 and do stuff every time. Cool. A while loop would say is better for, say, you're waiting for something and you're not entirely sure when that'll stop. So this while counter is less than 10. Like if this is all I wanted to do is console log the counter, a for loop makes more sense. A while loop is a little more if you're not sure exactly when it'll happen.
Like Def Grandma, we never knew when
exactly
we were going to say goodbye twice.
Yeah, and if we had a prompt that didn't, break the program for the while loop, then that would have been perfect. But yeah, cool. Good question. That's an important distinction to make. All right, I'm going to do one more JavaScript looping thing. And so I want to be able to say, I should be able to loop through something. So let's say I have, I have coding length, and I have this equal to an object. Wait, no, that doesn't make sense. Sorry, bad example. Let me think again. So let me say, pets. So I'm going to have, say, my dog is named Taz. My cat is named Artemis. And my bird is named Coco. I have this thing here. And I want to display just the names. I don't want to see dog, cat, bird. I just want to print those out. There's another kind of for loop we can use. So I can see, so I can say for. So let key in object in pets. So first I'm just going to console.log key. If I run this code, I can see all the keys. So I can loop through this data structure, this object, by just saying, go through all of the keys and show us each one. So now instead of doing that, I can just say, no, once I have the keys, I can just do that. Key. If I learn how to count, spell, oh my God, there we go. So now I should see just the names, Taz, Artemis, and Coco. So we did this already when we were reviewing Roman numerals, so I don't want to linger too long on it. But if you ever need to loop through a data structure, whether it's a object or an array. So if I do an array, so let langs equal Ruby, Python, I don't know why I'm looking up there, and JS. Then I can also say for let key in langs, or let's not call it key, let's just call it L for now. By console.log L, what do you think I'm going to get for this one? because we don't have keys for an array, we have something else, right? So we get the indices in this case. So probably call this, oops, wrong time to use in Command D. Index. So these different for loops are just set up in different, the for loops work the same way. We figure out how these things are stored, whether it's with an index or a key. And we can loop through those indices or keys and do whatever we want with them using a for loop. Any questions about that? Okay, cool. Let's see here. All right, so now I'd like to talk a little bit more about Python. So touch. All right. So you got a big Python overview from John yesterday. There's just a couple of things that we didn't get to, so I'd just like to talk about those real quick. So we talked about, arithmetic, data types like booleans, numbers and strings, comments, printing and getting values, conditional logic and loops. I think the only thing we didn't talk about are data structures, which again should be very, very familiar to you all, because in Python and JavaScript, data structures are more or less the same. So in JavaScript, we've got arrays. In Python, we've got lists. That's their official name. They're called lists. They're arrays. They work exactly the same way. So I do, days of the week. Set it up with the brackets. Monday, Tuesday, or else do Mon-Tues just for that. One of these times I'm going to get used to this keyboard. So Monday, Tuesday, Wednesday, Thursday, and Friday. So if I want to access, so if I wanted to see days of, if I wanted to take a look at Wednesday, how would I get that? Yep. So I would say, give me the thing at index 2, because indices always start counting at 0. Yep. And if you ever want to make a copy of a list, you can always do something like this. So I could say days equals, using the list command, and just say days of the week. And that just makes a copy of the list for you. You can also convert many things into lists. So say, for example, I've got a string. I can actually print out converting this string into a list. And I've just got it broken down by character.
What would be the difference between doing days equal days of the week versus list days of the week?
So you have to correct me if I'm wrong, but part of it is just kind of how we do with the data. If I say, I'm going to try something. What's the difference between making a copy of the list and just assigning it to a variable? So if I say days equal, I'm going to see, this is something I'm not entirely sure what the outcome is be, so I'm going to try that, days of the week. I'm going to say days.pop, and .pop is something that removes something in a specific index. So I say I want to pop out the 0th one. So I'm going to print out days, and then I'm going to print out days of the week. And I'm going to see if there's a difference. I'm going to delete this print statement. Out that is. So, okay. So I printed out, so I assigned days equal to days of the week. And I called pop on the days variable. And then printed out days, and then printed out the original variable, days of the week. And the result is the same. They both it took Monday out of both of them. But let's say I wanted an array that was distinct from that particular array. I wanted days of the week to remain Monday, Tuesday, Wednesday, Thursday, Friday, but I wanted days I want to be able to change that while leaving the original one intact. If I do it this way, now days of the week remains intact. Days of the week remains intact while days has changed. And that kind of deals with how data is stored and what variables actually are. Because when I define days of the week equals this list, I'm assigning some memory in my computer to keep track of this list of strings. And I'm saying whenever I refer to days of the week, I'm referring to this. And then when I make a new variable called days of the week and assign it directly to equal this, I'm saying this new variable equals the exact same list. It's not just a picture on our screen. It is a place in our computer that has been set aside to hold that. But when I do list, I'm saying list days of the week. I'm saying make a copy of this. Save an entirely different list to our computer. And that way we can change one without changing the other.
I get what we're doing with list, but is that unique to Python? I feel like JavaScript has had a different behavior in the past because if I'm going to manipulate a number, I'll set it to a new variable.
Yeah. So I don't remember which one JavaScript does because there's something called pass by reference versus pass by value. And I'm trying to remember which one is which now.
Yeah, this looks like reference.
Yeah, so Python is pass by reference. Yeah, thank you. It's
okay.
So a variable refers to a place like this. Other languages that are passed by value would say, whenever I assign it to a variable, I'm essentially creating a brand new thing of this. I just want the value of it, not the actual data thing. I don't remember which one JavaScript does. I guess we can test that real quick, right?
I don't need to hold this up, but yeah.
No, this is something I'm actually genuinely curious about.
Depends on the built-in method you're using. Sometimes pass by value.
So if I say,
I was really surprised to see it behave like that.
If you look at the documentation for each language you use, it'll tell you that it acts, it creates a new array or it acts in place.
and then I'm going to console.log array and new array. So if JavaScript in this case is acting as pass by reference, array and new array should both have hello in it. If it's passed by value, then only new array should have a hello in it. So would be node JavaScript. Let's see what happens. Oh, so in this case, it's also passed by reference.
Okay.
Yeah, good question.
I think arrays and objects are passed by reference, and strings and numbers are passed by.
I think that makes more sense.
Yeah. Also,
Not by language, but cool.
yeah. Also, I just remembered a quirk about strings I've been meaning to talk about. This is kind of a thing that Python does that a lot of other similar coding languages don't. Strings in Python are immutable. So if I can see, if I wanted to see just what the first letter was, I could do, print string 0, right? And that should give me W. Get these guys out. But if I wanted to reassign that, if I wanted to change it to a capital, I would say, oops. If I wanted to say string 0 equals capital W, it'll say string object does not support item assignment. So strings have in Python, have some similarity to arrays in that they have index numbers that you can look at, but you can't reassign them like that. Once you've assigned a variable to a string, you can't change it. You can make a new string, but you can't actually reassign letters this way. Other languages do let you do that. Python doesn't. So if I wanted to change that to a capital W, I might do this. I might want to say like list equal, well, not list, that's a bad idea. String list equals list string. Then list 0 equals capital W, because I can reassign things if it's a list. I'm getting it. Okay, and then I could just say list.join. Join can take a list and convert it into a string. Oh, maybe it doesn't. What am I thinking of?
That's an array
Hmm.
function.
Oh,
Let's take a look at that.
I think it could be string.join.
You have to say how you are joining them.
Yeah.
Oh,
yeah.
yeah.
That's where you want to put it.
Oh yeah, so I need to. No, it still
I think
says.
it's the other way around.
It's because, well, you can do it, but you can use the built-in string method for capitalization.
Yeah, that would be easier. I agree. I just wanted to try this out. So bring list join.
It should have been.
So I know there is a join function. I was making that up. Maybe I just have it. S dot. Oh. Okay. So.
So it was just backwards.
Okay. Oops. So it'd be join. Nope. Wait.
And, yeah.
All right. One more time. There we go. And there is a capitalized function that would make this problem a lot easier.
Yeah.
But I just wanted to explain, the difference between working with a string versus working with a list. This is one of those things where I'm used to working with Ruby, and Ruby is so similar to Python until it isn't. All right, so those are lists. Any questions about those so far? Okay, so moving on. Again, Python doesn't have objects. Python has dictionaries. But it works exactly the same way, almost. Key value pairs. And then if I want to find something specifically to this, I would say dict name. Got to print it out. There's my name. And if I need to reassign something, it's pretty simple. I could just say, I want to change my name. I can reassign it, no problem. And if I want to remove something, if I don't want people knowing how old I am, I could use something called the delete function. I could say del dict age, and then print out the entire dictionary instead of just my name. So now I've just got my name, the age has been removed. Generally speaking, anything you've been doing with a JavaScript object, you can do in a Python dictionary. For now, there's JavaScript objects actually have a lot more functionality, because a JavaScript object, you can actually assign a function as a value, which makes them a lot more flexible, I suppose. But when it comes to just assigning key value pairs like this, there's not really much new on the table. If you want to we can take a look at all the Python dictionary functions just to see, you want to see them all. I already have that up. We kind of went through that already. So they have a lot of methods you can use. Any questions about dictionaries? All right, so I'm going to go to one more Python thing, and this is something that's The big difference between Python and JavaScript. Python has something called a tuple. A tuple looks a lot like an array. I wanted to print out this tuple. One, two, three, four, all in a row. If I want to just get the last one, I could do at index -1. Give you extra index -1 in anything, it'll just give you the last thing in the array.
Oh, so that you wouldn't have to figure out how many there were.
Exactly.
Does that work for like -2 would give you the next to last one, et cetera, et cetera?
Yep.
Kind of cool.
Yep. So yeah, that's a lot easier than doing like len -2. So that's cool and all. So the big difference between a tuple and an array is tuples are, you cannot change a tuple at all. If I wanted to say, I wanted to reassign 1 to equal this, blows up my program. Tuple object does not support item assignment. If I wanted to add something new to the tuple, like, .append, which is something you can do with lists, tuple object has no attribute append. Tuples are completely immutable. There is no way to alter a tuple once you have defined it. If you want to add more things to the tuple, there's only really one way to do that. I could say tuple1 plus equals, I could give it another tuple, like 5. And when you're defining a tuple with just one thing in it, you need to put a comma after it to show that it's a tuple and not just a variable with a parentheses in it. And if I print out tuple1 now, oops. Now it's got that. But the reason it does that, what's actually happening is I've essentially created a brand new tuple of 1, 2, 3, 4, 5 and assigned that to the tuple1 variable. This original tuple, as we have assigned it in our computer, will remain the same until we clear all our data.
I don't understand the difference. You said it stayed the same, but you also said that you. How did a new one get created? If it's.
Yeah. Well, I mean, to add to his question, because I feel like I might have the same question. I get what it's doing in the background is it's deleting the old one and making a new one with the 5 variable. But isn't arguably that's what it's doing when we're appending like a list, right? Yeah. If you say change the 3rd variable, wouldn't it be deleting the old one and making a new list with the new 3rd variable?
Good question. And truth be told, I'm not really sure what Python is doing in the background when it does its lists.
Not necessarily could be creating a brand new place in memory, or it's just replacing, or essentially adding to the same place in memory.
Okay. But in any case, whatever is happening, this is the only way to extend a tuple, is to add 2 tuples together, which gives us a brand new tuple. Otherwise, your tuple is just going to look like this until you die. And yeah, that's pretty much all there is to it. Tuples, I don't know how often they're going to come up. Like, there is one way of doing string interpolation which requires tuples, but f-string is easier. So
are you talking about that format?
Yeah, there's I think it's something like you use like %s or something, and then you put a tuple afterwards, and that tuple is all the values you want to put in for that in the right order. I'm honestly let me take a look at how that exactly works, because it's something I don't do very often because f-strings are just so much more convenient. Not sure if this is really. So maybe this has an example of. This blog seems pretty good. Okay, percent formatting. OG of Python formatting. Here we go. Here's an example. So we have a variable called name, age is 74, then we have these percent s's, and then a tuple with the variables we want to insert there. So this is how we used to do string interpolation, is that you would have percent s's, and then you would say percent, and then a tuple with the things you want to put into these percent s's in the order they're in. Not great, because as you can see, this is what it can look like. They also have .format, which also, that's just a method, but it's more or less the same thing. So F strings, they're awesome. All right. Oh, yes?
The, I can ask him right now.
Okay. All right, so those are tuples. It's important to be aware of them, but generally speaking, if you just want to hold a certain number of things in order, and you anticipate that might change at all, stick with lists. All right. Any questions about tuples or data structures in Python in general? All right, anyone from remote? Just want to make sure I'm not overlooking anything. Okay, in that case, we're going to take another break, come back in about 10 minutes, so 9:52. We're going to talk about TDD.